two equal charges, 2 into 10 to the power minus 7 coulomb each, are held fixed at a separation of 20 centimeter. A third charge of equal magnitude is placed midway between the two charges. It is then now moved to a point 20 centimeter from both the charges. How much work is done by electric field during the process? So if I draw this configuration, so over here the question is saying that the two like charges are placed at a distance of 20 centimeter, and a third identical charge is placed midway between them over here. So we are considering that these distances are equal to r. So now in the question, the initial separation of 2r is equal to 20 centimeter. So over here I am writing that r equals 10 centimeter, which we will use it as 10 by 100 meter in SI unit. Now this was the initial configuration, after which the question is saying that the charges are placed such that the three forms an equilateral triangle, that is they are equidistant from one another. So the system is going to look like this. So this is the final configuration for this particular system, and the separation between them becomes 2r, that is 20 centimeter. So all these distances are equal to 2r. The question is asking the amount of work done by the electric field during this process. So if I write the initial potential energy for the system, so I am calling this as charge 1, this is 2, and this is the third one. So this is 1, this is 2, and this is the third one. So Q1, Q2 and Q3, they all are equal in magnitude, and that is equal to 2 into 10 to the power minus 7 coulomb. So if we first of all write the initial potential energy of the system, we write it as K Q1 Q2 upon 2R plus K Q1 Q3 upon R plus K Q2 Q3 upon R. And the final potential energy is written as K Q1 Q2 upon 2R plus K Q1 Q3 upon 2R plus K Q2 Q3 upon 2R. So these are the two values of potential energy of the initial and final system, and then we can write that the work done equals U2 minus U1, that is the final configuration minus the initial configuration. So if we subtract the two, these two parameters will eventually cancel out, and we will be left with the equation K Q1 Q3 by R half minus 1 plus K Q2 Q3 by R half minus 1, and we will write the magnitude of the work done the question is asking for. So if we substitute the values over here, we get KQ square by 2R minus KQ square by 2R, which we can write it as eventually KQ square by R with a negative sign, and since we are only calculating the magnitude, we can write it as 9 into 10 to the power 9. Q square can be written as 4 into 10 to the power minus 14, and the distance can be written as 10 by 100 over here. So on putting the values over here, we obtain equivalent value of 3.6 into 10 to the power minus 3 joule. So for this particular question, we get 3.6 into 10 to the power minus 3 joule.